Good morning, everyone. My name is Deirdre Denman, and I'm the Marketing Coordinator at EandM. Thank you for attending our webinar this morning titled Utilizing IO-Link to Unlock Your Sensor's True Capabilities. After the webinar, we'll be doing a short Q&A. Please type any questions or comments into the Q&A box, the chat box, or you can email us at webinars@eandm.com. I'd like to introduce TJ Singh and Eric Keller, SIC Product Specialist at EandM, and they'll be your presenters for today. I'll turn it over to TJ to get us started this morning. Good morning, TJ.
Thanks, Deirdre. All right, good morning again, everybody. Thank you for joining us today in the webinar. We will be talking about IO-Link, which is a smart sensor technology. The webinar will include like a basic introduction to IO-Link, what it is, how it works, some benefits for you, and then we'll also do some live demos. And as Deirdre mentioned, we'll have some Q&A in the end. So firstly, what is IO-Link? In simple terms, IO-Link is a bidirectional point-to-point serial communication protocol that is used to communicate with sensors and or actuators. Also, IO-Link is the first standardized IO technology worldwide for communication with sensors, and is also recognized by the IEC standards 61131-9. Also, another important thing to understand is IO-Link is not a proprietary technology, which means that not one sensor or actuator manufacturer is taking all the decisions. It's made up of like a consortium of members, which are always adding new members, and together they work on basically the capabilities and developing new technologies inside IO-Link. And as of May 6th, we have 280 members in this consortium. There are some key components for every IO-Link communication to take place. So firstly, IO-Link master block, which can be 1, 2, 3, or even 8 ports capable, depending on how many sensors you have. And each port on a master block is used for one particular sensor, since this is a point-to-point communication protocol. And another misconception that IO-Link is just for basic sensors is not true. In reality, it can actually support different kinds of sensors, from RFID reader heads to motor starters and even passive hubs and even more. And all you basically need is a 3-wire unshielded cable for this communication. A very important component is a IODD file in IO-Link system, which is actually generated by the vendor or the manufacturer of that particular device. And I'll talk more in other slides about it, but this is a key component for IO-Link to basically function with the IO-Link master block. Also, you need an engineering tool for configuring and assigning parameters of IO-Link. And you can see in the left, that's an IO-Link master block, and that's pretty much how the communication channel looks like, with sensors at the bottom, which are going to be talking to the master block, and that communicates it over the field bus levels. So all you need is a cable, basically, to talk from the sensor to the master for IO-Link communication, which can be a 3-wire cable. And this also follows the international standards for pin assignments. So 24 volts is your first pin, the third one will be your ground, and then fourth pin is the IO-Link channel, unless you want to use it for SIO. Another important thing is the maximum cable length between a master block and the sensor can be 20 meters. So we have 4 data types in IO-Link communication. First is process. This represents like the latest state of the sensor. It can be the speed or the distance in case of laser sensors. And this is transmitted cyclically, which means this is going to be spitting out data at regular intervals. And generally, this data is consisted of like 2 bytes, but the capability of process data can actually be up to 32 bytes if your sensor has a lot of other things that it is sending out. Then you have value status. This is again cyclical data, and it is also part of process data. So this is just going to be in the same array of the process data, and it just validates the actual process data coming in. Coming on to device data and events. So these are part of service data and are very important and actually show the power of IO-Link. So you actually get detailed information about your device, like basic information such as vendor IDs, serial numbers, pictures of your sensor, and all diagnostic informations as well. And device data is acyclic, which means that you actually have to send in a request for this data to come to you, which happens mostly at the IO-Link master blocks, but you can also use function blocks or add-on instructions if you're having PLCs to request this data from the master blocks. And finally, event. Event again is acyclic data, and it includes all maintenance and warning data. So if you have like overheating or whatever, like a cable breaks, so all that information is sent over event. And event data can actually be used to directly put it on an HMI to show your alerts or warnings, depending on what you have in the system. And final component, IODD file, which is called IO device description. Again, it is an electronic description which is available for all IO-Link devices. So this actually stores all important parameters such as communication properties, identification data, process and diagnostic data, text descriptions of what each parameter means, and you also have a picture of the device itself as well as the logo of the manufacturer. So important point here to understand is that it's an XML format, and the structure for all IODD files has to be the same for any device from any manufacturer, since this is an international standard, and that allows you to use any IO-Link sensor over any IO-Link master block all across. And that is why it is all compatible, because there's this IODD format that has to be followed. And all these device parameters are actually organized in indexes and sub-indexes so that your master blocks can easily understand them. And another thing, you will always find these IODD files on the manufacturer website. And if you have troubles getting that, then there's a repository on the IO-Link website itself where you can actually download it. All right, so let's understand what happens in a system where you do not have IO-Link. For example, I have this plant floor where I have 6 sensors at the very base, and they're talking to the PLC, which is further communicating it on the upstream channels. And if there's an alarm that gets triggered off, that is sent to the controller, and that is sent over to the SCADA system where the supervisor comes to know about it. So now the supervisor obviously sends the maintenance crew, but this time, if you do not have IO-Link, all you're getting is a basic yes or no signal from your regular SIO sensors. So you do not know exactly which device went wrong, what happened, and it's a complete chaos. There's so much time spent in the facility on troubleshooting, and there's so much downtime because of that. And you can actually save all that, and I'll show you how. So instead of directly communicating your SIOs to your PLCs, what if you have IO-Link communication happening, and I have a master block in this picture, and this time when again an alarm goes off, you again get notified by the controllers to the SCADA and to the supervisor, and this time when the maintenance crew comes there, you do not just have a yes or no, like this time you actually have all detailed diagnostic information that the supervisor has over IO-Link, and he gives them to the maintenance crew, and they know exactly what to fix and how to fix. No waste in time during troubleshooting. So you save so much time. And another quick question is, like everybody asks, is why IO-Link? Why not just use other protocols which are already in the market? To explain this in a simpler way, I have this SICK MRS 6000, which is a LiDAR from SICK. Now, this is a high-end product, and it can actually detect distance of targets around it and can actually give you even angle values. Apart from that, you can get timestamp, device data, temperature, error codes, and whatnot. So all this information is available on this high-end device. But what happens, and I can obviously put it on a Ethernet protocol because it's already, I have so much capability, so adding this is not a value adder for me. So you might think, okay, because it's a high-end device, you have so much information. What about a basic inductive process? I mean, all this is giving me is like a yes or no, right? And you might think it's not capable of providing all that information, but you're wrong. This also has all these detailed information stored inside it. The only issue is how do you get it on the field bus protocols? How do you get it on that field bus levels? Because it obviously doesn't make sense to put on an Ethernet port and connect the sensors directly, right? I mean, the cost of the Ethernet cable itself might be more than the sensor. In this case, it makes more sense to have a distributed system. What if you can actually have something that can distribute the cost of the whole system on it? And here IO-Link master blocks come, where you can actually have 8 sensors connected on that same master block, and you can still bring it on the field bus level protocols. And this way you are actually distributing the cost. And that is the power of IO-Link. So obviously the very first benefit of IO-Link is that you are Industry 4.0 ready, or industrial IoT is supported by your facilities. Furthermore, from the consortium website itself, we have 3 pillars of IO-Link, which is simplified installation, automated parameter settings, and expanded diagnostics. Let's understand what this means. So firstly, you have simplified installations. So on the left, you can see the PLC in the cabinet, which has like a bunch of cables coming from each of these sensors, which are distributed across the plant, right? So with this, you have to strip each cable, run each wire, or you have special or multi-core cables, right? And at the end of the day, you are terminating everything in your cabinets. But on the right side, you have the same system, a bunch of these sensors, but you have an IO-Link master block, and all you're doing is simply using those standard M12 connectors, and you're screwing them on the hub. And in the end, you just take your Ethernet cable and put it on the PLC, and that's about it. So no more terminating cables, and you're using standard cables, which means you're not having long lead times and no expensive costs for those special proprietary cables. Another look at it, I have a passive blocks which will have like a multi-core cable, and you can see here, so you have to strip each cable. And in a regular scenario in this communication channel, whenever you add like a new device, to get that signal, you have to terminate a cable. I mean, it's physical efforts. So here in the IO-Link system, what happens, you just plug your new sensor in and you don't have to terminate cables now. All you're doing is just adding more EDS files and just adding those add-on instructions. And you're just doing a setup on your PLC program, and you're not doing any physical termination and all that. So that is, again, the advantage of powered IO-Link. The second pillar of IO-Link, which is, again, very important, is automated parameter settings. So it helps very drastically in 2 ways. So firstly, if you have to do device replacements, it is made very much easier with IO-Link sensors, because the master blocks on which you actually screw them on, you can have all the parameters for each of these sensors already stored in it. And all you have to do is just plug in the device the new replaced device, and it will automatically push all the existing settings into the same sensor, which is really helpful. And another important thing is changeovers. I mean, changeovers is always a pain point. I mean, if you have a high-end device, like you have a camera, then you can obviously change different recipes if you're running different products on the same line. And you can do that on the fly. You don't have to physically go there, push buttons, and do all that, right? So no, you don't have errors. But what happens if you have a sensor and you have to run various different products? You have like a different color liquid. You might have different bottle sizes, or you are even running different colored bottles. I mean, these are so many changeovers, and it's a really daunting task to go there, press buttons. And again, if you're pressing buttons, you are prone to errors. Human errors are always possible. But with IO-Link, you can actually set up your all these parameter settings in your master block or your PLCs itself, and all you have to do is run that program. And that can also be done with the HMI. I mean, you can just have the program, you can click that button, and changeovers are made so much easier. And moreover, you do not have downtime. So before, if you have to do changeovers, you have to stop the production line so that you can do the new teaching and then you do the whole process. But with sensors, you can actually do all that on the fly with IOLink. And the third pillar, which is again important, is expanded diagnostics, which are very specific again to the devices that you have. In my case, I have a W9 retroreflective sensor in this slide, and you can see the screenshot of the configuration tool from SICK. So the black line here basically represents the receiver light. So this is the amount of light that is coming back to the sensor. And when this black light drops, the trigger signal is sent. And another thing that happens in factories is that with reflex sensors, you have a reflector which kind of keeps getting dirty after a certain period of time, depending on your workings. And you have to keep sending the maintenance crew to like clean it up, because as soon as that reflector gets dirty, this black line is actually your received light. So this will drop off and this will trigger an output. So nobody knows, I mean, if there's an actual object or the reflector is getting dirty. And there is no way to know when a reflector gets dirty. But with IOLink, you can see in the screenshot, I can actually set up those quality levels for my device. And I have set it for 70%, which basically means that if this reflector gets dirty and if it is as dirty as it can only send back 70% of light, then I need a trigger signal. And you can see the visuals of it. This black signal, which is the received light, is getting dirty over a period of time. And I was making it dirty for this demo. And once it crosses this 70% mark, which is on the plot itself, you can see this red pulse is generated, which is my 70% trigger. So now you can do predictive maintenance, which is you can already know, okay, this is the time when I have to send my maintenance team to fix this issue. And they're not going repetitively, very frequently, nor are they being too slow about it. Now I'm timing everything, which is basically just giving me more productivity, and my maintenance crew is able to take care of other important tasks. Also, with a discrete IO or a SIO sensor, all you get is like a yes or no, right? So once I teach on those, it will set a threshold. But what happens if you're running different kind of materials? What if you want to play with that threshold? I mean, if I have different materials, I will have false strips. But with IOLink, this blue and turquoise light are my threshold. So if the black light goes below this, I need to trigger an output. And earlier, I cannot change it according to how I want. But with IOLink, I can actually drag these bars and pull them down or up and actually set a threshold where I want it, which means you can fine tune it. And that is the power of IOLink. And another important thing is CTA, which is called continuous threshold adaptation. And what happens in that is that when the reflectors keep getting dirty over a certain period of time, the threshold automatically keeps adjusting to that as well. And you can see on the graph, as my reflector is getting dirty, my CTA it's automatically doing its function, and this threshold is automatically coming lower. And when I clean my sensor, the received light is coming back up, the threshold automatically adjusts. And again, you can have these with 6 sensors, the power of CTA. And that was IOLink for you and some of the products that SICK has. This again is a screenshot from the consortium website, and they have it for every manufacturer. So for SICK, on the top 3, you can see these are the protocols that we support, that we can use our sensors with. And then we do have cables, and these are the list of products that we support with IOLink. And another look at the products that SICK has. So this is the portfolio. We have more variants, but from distance sensors to ultrasonics, encoders, and even a small LiDAR, we have everything over IOLink as well. And also we do have master blocks that can do 8 ports. And we have a nice SIG 100, which is like a slave module. So you can put your discrete IO sensors on this, and you can actually connect it to a master block to get enhanced functionalities. And also this can replace your passive blocks, and you can actually run logic on these slave modules itself. Now I have a nice demo. So you can see this is an inductive sensor and this is like a metal part, and I will show you this on my software. So this is, you can see a nice graphical view right now, and this is indicating the distance of my sensor to the metal part. And when I go lower, this inductive sensor sees the metal, and you will see that it changes. So with IO-Link right now, I am having so much data. You can see this, the type, the article, the serial number, even the device ID, and a picture. So this is all being pulled over IO-Link. Then I even have more details, such as the version of IO-Link, the minimum cycle time of my sensor, which is 5 microseconds right now. And then I have process data details as well. Apart from that, I can even see my internal temperature, which will change if I hold it in my hand for some time. I mean, it's going to go up. And so all these things are coming over IO-Link. And if I go furthermore, so here you can see another nice graph. So if, first of all, I have an inductive sensor, which is doing discrete IO, all I get from it is like a yes or a no, right? So in my case, if I have to, so in my case, if you see right there, as I come close to a metal part, this thing drops. And this is my threshold. So if the sensor sees a metal part at like a 4.5 millimeter distance, it's going to trigger off. But with IO-Link, I can actually change the threshold as well by just dragging it. So I want my trigger. The trigger is represented by this yellow pulse. And once I am below this threshold, it triggers. So you can see how much intuitive this is. I mean, I can program it however I want it. And you also have different modes, such as a window mode. Earlier, all these special functionalities were only available on time of flight sensors, which had like smart chips on it. But now, as soon as my signal is between this, sorry, my hand is too shaky right now. So you can see right there, the signals are on as long as I'm in that window. So I'm getting these kind of special features from just a very basic inductive procs, which is amazing. And I have 2-point modes where I have upper and lower thresholds. And I can even do other functions such as set hysteresis. So if I do 500 millimeter hysteresis, you can see right there. And another cool part is in my process data, if you noticed it or not, I don't know if I go back here. In my process data, I have bit 0, 1, 2, 3, 4. So these actually are values coming, I'm getting 4 outputs, if you may say. And then I have counter values, which is from 18 to 31, which means that I can actually have outputs in my process data for 4 outputs. So now I can actually trigger 4 outputs with 1 inductive sensor, which is amazing. I mean, you're not just getting 1, but 4. And here at the bottom, you can see I'm getting real-time decimal values of the distance I am seeing, my inductive sensor is seeing. So it's changing. And it doesn't just stop here. You also have logic. So I mean, if I have like this is a 4-pin sensor, and obviously when the 4th pin is doing IO-Link, I cannot use this one, but pin 2 is free. What do? I want it on like a, let's say, external input. And I can turn my external input on. Now I can do like a reset counter whenever I powered the 4th pin. Or I might want it to trigger off with a Q1. And you can see right at the bottom, this is so visually you can see it. And that is the power of IO-Link. And now Eric will take over and give another nice example.
Yeah, thanks, TJ. Let me just get my screen shared. We'll run through this pretty quick because I know we're kind of getting up on close to the time limit here. Deirdre, can you see my screen?
Yep, I can see your screen.
Okay, perfect. So what we have set up here is a SICK DTEC4 light curtain. And what I wanted to show is that IO-Link can be used even on, safety devices. So what we're getting here is just a quick view of the DTEC4 and its current status. So we're using the Sophos engineering tool to connect to the light curtain over IO-Link. And this is something that, is traditionally has not been possible in the marketplace. SICK recently released this functionality into the DTEC4, and it's great for doing configurations and diagnostic work on your light curtains, because traditionally you would have to, you would get a fault come from a light curtain, supervisor might come down and say, hey, go check the palletizing light curtain, it's not working right. Well, now, if you have all of your light curtains connected via IO-Link over your network, you don't get the safety functionality, but you do get this diagnostic functionality. And I really want to highlight that with, just to show that IO-Link is really powerful when it comes to safety as well. So when you connect to the device, you kind of have a home screen. It lists all your generic, status information about the light curtain. You can see the part number and model number of both the sender and the receiver. You can see its current status here. You can see if I stick my hand in the light curtain, it goes red to tell me I have a fault. We have our other state indicators. Right now this diagnostic indicator is kicked on, telling me that I have the ability to do muting, which is really cool, because normally you would have to pull the system plug off and look at the dip switches and figure out how that configuration is set to tell you what you have as functionality. We can even do a little bit of configuration. This is not really a live configuration, since the DTEC4 system plugs rely on physical dip switches to set their configuration. But we can actually read this configuration, maybe take a screenshot or somewhere and save it to a file so we know what every single light curtain is configured as. You can see that we have the checksum of the receiver that tells us that we have a good configuration. You can see here I'm on exit monitoring. I have input signals from 2 different muting sensors. I've left the smart presence detection off, which is, just a feature that you can switch, which is great. The other handy thing when it comes to diagnosing potential faults inside of a light curtain is the status of the beams. As you can see here, every beam on the light curtain is this dark green color. As I pass my hand through the light curtain, you can see where my hand actually is inside the light curtain, which is really nice. And you can see that the quality of the light received inside the light curtain changes. So this is actually very useful when configuring, your light curtains, either during your commissioning phase or troubleshooting them, because as you can see, some of those like light green beams that pop up are a strong-ish signal. You can see the yellow ones are weak. Maybe this helps you with some of your alignment to get the light curtain up and running properly to where you can get all of these as a dark green. So this is a pretty powerful tool. You can connect up to it while you're doing your commissioning and have the laptop right there, and you can see, and you can do some runs on it. You can see what its status is, maybe what each of my beams are. If I wasn't perfectly aligned, these top beams might show a weak signal. The other really powerful feature using IO-Link on the SICK DTEC4 light curtains is this data recorder. So say you get a few alerts from operators saying, hey, this light curtain false trips, every day at 4 o'clock. Well, we can come in and actually set this data recorder to run at 3:50 to 4:15 in the afternoon. And we can do this remotely from the control room as long as we're connected onto the network through IO-Link, which then filters up to the field bus level. We can do this remotely. We don't even have to be at the light curtain. I can come in and I can look at the different signals. So I can look at how the OSSD is acting. I can look at the the standalone host object. I can look at a whole bunch of different filters. Is the EandM going on or off? Is my reset override app input active? I can look at all these things, and I can hit this record button, and you can see that as I started recording, all my timestamps are coming across. You can see the status of my various bits and everything. And as I pass my hand in there, look, okay, it tripped. it'll trip again. And I can record all of this. And this is very powerful when I need to diagnose something. I can do this, and I can, save this file for later, and I can do it over multiple days to see, hey, is this happening at the same time, or what is causing these false trips to happen? I know I'm just about out of time, but I do want to show that we do have an error history as well. So this shows the most recent errors in the light curtain. We also have a switch off analysis. Every time I broke the beam, it gives you a date and a timestamp. And then finally, we have the dip switch assistant. So say you want to change the configuration, you just come in and select the features you want, and it'll tell you how to configure the dip switches, which is also really powerful. And so with that, I'll hand it back over to Deirdre for some questions.
Thank you, Eric. And thank you, TJ. As mentioned, we'll open it up for a couple of questions. Please type any questions you have into the chat or Q&A box, or you can email us at webinars@eandm.com. We did receive a couple of questions during the webinar, so we'll get started on those first. So the first question is, can master blocks also run as a discrete output sensor?
Yes, they do. So you can actually set each port for standard input, or you can do it deactivated, or even you can do it standard I/O. Yes, you can do it.
Okay. And then what is the difference between process and server data?
So process data, that's a nice question. So process data is basically what your sensor is actually seeing at that time, which means if it's a laser sensor, so it's constantly spitting out that distance value, which is what you actually want from it. And service data is more like where you want specific things to change, or you want certain thresholds to get adjusted. So that is basically service data.
Okay. And then the next one is an IO-Link sensor also has a standard I/O functionality. Do we have to turn on IO-Link, and how do we do that?
Yes. So normally each sensor will have that standard output too. So what happens is that when you plug into a master block, there's a request that is generated that is also called like a wake up sequence that the master block sends the sensor, and then it has to respond within a certain microsecond. And once that is done, it basically starts the receiving mode, and it automatically changes to an IO-Link sensor. So that happens on the fly when you connect it on the master block. Can you hear me?
Okay, perfect. And then let's see, let me double check our chat. And then can you have both FlexLink and IO-Link?
FlexLink?
Yes. Can you have both FlexLink and IO-Link?
I mean, yes, you can use the FlexLink as the final output. You can just connect it to a master block, but at the end of the day, you will just get that a standard discrete output.
Okay. And I believe that concludes our Q&A section. Thank you, TJ and Eric, and everyone who attended today. If you would like to review any portion of this webinar, a recording will be available on our YouTube channel and on our website at EandM.com. Thank you again, and we hope to see you at our next webinar.